Hey everyone, today I'll be doing the term 1 final quizzes. So I'll start off with the 3.1. So this is our first question. If y is equal to all of this, then what is y prime? Okay, so first of all, what I would do personally, you can do it in other ways, but this is what I would do personally, is I would split up the fraction. So you'd get 2x power of 8 over x cubed minus 3x to the power of 6 over x cubed plus x to the power of 4 over x cubed. Okay, now this is actually much simpler now. Why? Because these powers will cancel out, not fully cancel out, but you can simplify. So 2 over 1 will stay as 2. X power of 8 minus divided by x power of 3 will give you x power of 5 minus 3x cubed plus x. Right? Now you can derive this. So deriving will give you, this is a 5. So 10x to the power of 4. Remember the rule for the derivative before I actually start fully. If y is equal to ax to the power of n, then y prime is equal to n times ax to the power of n minus 1. Okay, so now that we know this, we can keep on deriving here. So minus 3 times 3 is 9, 9x squared. Okay, the derivative of x is just 1. So this is my answer. Okay, question 2. Okay, so the line y equals negative 8x cuts the curve y equals all of this 1 minus 3x into x plus 3x squared at the points a, b, and c such that x of a is less than x of b and is also less than x of c. So fill in the blanks. The coordinates of a, b, and c. Basically what they're telling you is here, okay, you have a curve. This curve will make a cubic. This is a cubic curve. So what I'm gonna do is I'm gonna sketch it. Actually, this is gonna be a negative cubic. It's gonna be something like this. Okay, now the line y equals negative 8x, so it's gonna be like this. Okay, so this is your first point, this is your second point, this is your third point, this is a, this is b, and this is c due to the restrictions. You can notice at these points, right, the y coordinate of the line negative 8x is equal to the y coordinate of the curve, right? And that's exactly what we're gonna do. So what we're gonna write is y equals y, which means negative 8x is equal to 1 minus 3x into x plus 3x squared. Okay, so we have this. However, we can't really work with this and then remove this to the other side. So what we're going to do is we're going to expand our brackets. Okay, you're going to distribute 1 into this term, into both terms on the other bracket, and negative 3x onto both terms in the other bracket. You will get x minus 9x cubed. Okay, so now you take negative 8x to the other side, it'll be 9x, and since you know negative 8x will be positive 8x when you take it to the other side, x plus 8x, 9x minus 9x cubed will equal to 0, right? Now, you either solve this on your calculator or very easily, you can take out 9x as a common factor, so you'll get 1 minus x squared equals to 0. Now, this means that 9x will equal to 0. What does that mean? X is equal to 0. It means that 1 minus x squared is equal to 0, which means that x squared is equal to 1. So x is equal to plus or minus 1. Those are your coordinates. Now, they told you very clearly x of a is less than x of b, which is less than x of c. Right? So what does that mean? That means x of a will get the least value of x, which in our case is what? Negative 1. So I'll just trace it here. So negative 1. Okay. Now, x of b is going to be 0. That's this value we got here. Right? So 0. Then x of c is going to be positive 1. Okay. Now, done. This part's done. By the way, remember the curve. Remember the expansion of this curve. We're going to need it for the second part. This was just for reference. It was y equals 9x, or sorry, x minus 9x cubed. Okay, this is the same thing as that. You just expand the brackets, you'll get x minus 9x cubed. Okay, now, how do you find the y coordinates? Because we found the x. Okay, but what about the y? Very simply, you plug in the x coordinates into this line or into the curve, whichever one you want. It's obviously way simpler to plug it into the line y equals negative 8x than into y equals 1 minus 3x into x plus 3x squared. It's inefficient to plug it into the curve. So what you're going to do is you're going to plug it in to the line. Why? Because remember, we said I have the exact same y value. So you're going to plug in negative 1 into negative 8x. 0 into negative 8x, and 1 into negative 8x. What will you get? You'll get, plug in negative 1 into negative 8x, negative 8 into negative 1, you'll get positive 8, which is what you get. Now 0 into negative 8x, negative 8 times 0, 0. So y is 0, and then plug in 1 to negative 8x, you'll get negative 8 times 1, which is negative 8, and those are your points A, B, and C. Okay. Which of the following statements is true? Select all that apply. The tangents to the curve at A and C are parallel, and the slope of the tangent to the curve at B is 1. How do you find this? Tangents to the curve. To find the slope of the tangent, okay, you have to check their slope, or which is what I said. You have to check their derivative. So, derive this function. Y prime is equal to 1 minus, this will be 27 x squared. Okay, very simple, very easy. So now you're just gonna plug in the values of x at A and the value of x at C. So y prime at x equals negative 1. But if you want to denote like derivative at a certain point, you do it like this. Y prime or dy by dx. You can denote it like this. Dy by dx, f prime of x, whatever, at x equals to negative 1. Now you just plug it in. So 1 minus 27 into negative 1 squared. So this will give me what? 1 minus 27 to negative 1. So this is going to give me negative 26, right? Wait, how can I not do this in my head? Yeah, negative 26. Why was I second guessing myself? Okay, so this is at x equals 1. Now let me do it for x equals 2. So dy by dx at x equals, not at x equals 2, at x equals positive 1. So this will give me 1 minus 27 into negative 1 squared, which is the exact same thing. It will give you negative 26. So yes, it is true they are parallel. Why? How do you know that they're parallel? They have to have, their derivatives have to have the same value. The slope, their gradient, has to be the same, because remember what the definition of parallel lines are. They have different y-intercepts, but more importantly they have the same slope. And in our case, you can see here negative 26, negative 26, they have the same slope, so they're parallel. Okay, now the slope of the tangent to the curve at B is 1. How do you find it? You just, since B has the x coordinate of 0, you're gonna do dy by dx at x equals to 0. It was 1 minus 27 into 0 squared. So you're gonna get, this is just gonna give me 0. So it's gonna give me 1, which is indeed true. So those are our two options. This is the answer. Moving on. Okay. This one is easy once you get it, but I need you to focus with me. Because if you focus with me, it will be really easy. But if you don't, it's very easy to get lost in this. So what do you do here? Let me just, okay, sorry. You have, let P of x represent, let P into, which is, this is the coordinates of P. X, comma, 3x squared represent any point on the curve, which is C. Let Q be a variable point on point C, whose abscissa, what does that mean? Abscissa means x value, or x coordinate, okay? Is x plus delta x. So right now, what do we know about Q? Q, all we know is the x coordinate as x plus delta x. We don't know why. We're gonna leave it like this. Let me just move it a bit closer. So Q is x plus delta x, comma, we'll leave it blank because we're gonna figure it out now. So fill in the blanks, blah blah blah. The slope of the secant line. Now, say the curve is take a quadratic. I don't know. We're not gonna know now. We were gonna know in a bit, but not now. So take it's a quadratic function. Okay, it's U-shaped. It's a parabola. Okay. Now, say you have this point here. Let's call this one Q and this point P. The secant line is just the line that's joining these 2 points. It's a straight line that's joining these 2 points. Okay. So the slope of the secant line, you're gonna have to find it by doing what? The gradient, or the slope, is equal to y2 minus y1 over x2 minus x1, which is also called delta x, or sorry, delta y over delta x. So we're not gonna use the delta y over delta x definition. Let me just close this because I don't know why it keeps opening it. We're gonna use the fact that the gradient is equal to y2 minus y1 over x2 minus x1. Done. Okay, so now how do you find the y value of p? Remember, or q, sorry. We said we have the x value of q, x plus delta x. This thing means delta, but we don't have the y value. So what do you do here? Well, if you notice here, the p is x comma 3x squared, right? And what is essentially a function? A function is any value that, any equation that maps x onto y. So f of x is equal to 3x squared, right? This is the simplest definition of a function. It's the basic definition of the function. What are we gonna do with this? We're gonna use this into q. What does that mean? We're just gonna plug in x plus delta x as x, and we're gonna get the y value from it. So f of x plus delta x is equal to what? 3 into x plus delta x squared. Okay, now we're gonna expand this later, but for now we're gonna leave it like this because I don't have space. So 3 into x plus delta x, close it, square. Okay, now we're gonna use the definition of the gradient, the slope. So m is equal to y2. Let p be y2. Let p be x2 comma y2, and q will be x1 y1. Doesn't really matter, it's still the same value. So 3x squared minus, or actually for simplicity, because this one we're gonna have to expand it, q is x2 y2, this is x1 y1. Okay, just to simplify it. So 3 into x plus delta x squared minus 3x squared over x2, which is x plus delta x, minus x. Now x minus x will cancel out, so we can just erase them. This is what we have for our gradient. Now, this is technically correct, but obviously it's not simplified. So what are we gonna do? We are gonna simplify it. So how do we do this? Expand this. So m is equal to 3 into x squared. Remember the remarkable identity a plus b squared. Let me change the color for this. Is equal to a squared plus 2ab plus b squared. Okay, so we're gonna apply this. Now, x squared plus 2ab, so 2x delta x, plus delta x squared. Let me just start erasing this because I don't need it. Okay, minus, I'll remove this, minus 3x squared, all over delta x. Okay, I'm just rewriting it so I can simplify everything. Okay, now, I am gonna substitute the 3 into so I'm gonna distribute the 3 into my brackets. So I'm gonna get, why am I in Google Messages? 3x squared plus 6x delta x, okay, plus 3 delta x squared minus 3x squared, all over delta x. Now 3x squared minus 3x squared cancel out, so what am I left with? I'm left with this. Right? Now, this, if you notice, it can be factored out. I have delta x, and I have delta x. So, I'm going to erase this because I don't need it anymore. I have the simplified version. M is equal to delta x into 6x plus 3 over delta x. Delta x and delta x cancel out. I don't need you. So, m is equal to 6x plus 3. Or sorry, this was delta x squared, right? Yeah, this is delta x squared. So when you take delta x out, just be delta x. 6x plus 3 delta x. I'm done. This is my my slope, which is the answer. Okay. So this is what you have. Now, as delta x approaches 0, the slope of PQ approaches what? So this is what we call a limit of a function. So what are you gonna write? You're gonna write limit of delta x approaches 0, 6x plus 3 delta x. What is this equal to? You're just essentially going to substitute delta x as 0. It's going to equal to 6x plus 3 into 0, which is going to give me what? 6x. And this is my answer for part B. Okay, now, part C. When x equals 1, the gradient of the curve C is what? All you really have to do is, you see this value here that they give you, plug it into this value here. The one where you get when you take the limit of delta x to approach 0. So basically, you take the given value of x in part C and substitute it in part B, you'll get C. So substitute x equals 1 into 6x, you'll get 6. And that's the answer. Okay. I don't like how this keeps opening. Now, moving on to question 4. This is very, very easy. It's an application of y prime is equal to n times ax to the power of n minus 1. So what are we going to do here? Take 5 down. 5x, 5 minus 1 is 4. And this is your derivative. Done. Now, moving on. Okay, here there are multiple ways of approaching this. You can use the normal derivative rules, or you can use the product rule. Now, it's preference, whichever one you want will work. It doesn't really matter to me, or it doesn't matter to you. I'll explain the product rule in the next section. So, for now, because it's section 3.1, I'm gonna do it using the normal rule. So, y is equal to 10x, I'm distributing. So, 2x cubed into 5x squared, 10x to the power of 5. Now, 2x cubed plus 3 into plus 3, it's gonna give me what? 6x cubed. Plus, distribute the 1, 5x squared plus 3. So, y prime is what? Y prime, take 5 down, 50x to the power of 4. Plus 18x squared. Plus 10x. And remember, the derivative of a constant is always 0. So this is my final derivative. That's it. Done. Question 6. The point on the curve y equals 4x squared minus 9, at which the gradient is 24. This is very easy. Derive this. So y prime is equal to what? 8x. That's it, right? Yeah, 8x. Now, they told you the point. So you don't know the point. You don't know what to plug in x for. The gradient is 24. So y prime, which is what? The slope of the tangent, or the gradient, okay, is equal to 24. So what do? You just swap 24 for y prime. So 24 is equal to 8x. What does that mean? X is equal to 24 over 8, which is 3. Now, okay, that gave me the x value. How do I find the y value? Plug in 3 into the normal y, right? How am I going to get y? Just plug it in. So y is equal to 4 into 3 squared minus 9 will give you 27. And that's the answer. Okay, question 7. Now, this one, it's easy if you focus, like the other one. Because if you mess up in your first stages of working, the rest of the question is wrong. So if you get the concept correct and you focus while you're working on this question, you'll get it right and it's 3 marks. But please, please, please focus on how you work on this question, because one wrong step, the entire question is wrong. So the equation of the normal line, okay? How do you find the equation of the normal line? First of all, they told you that the abscissa of this point is x equals 1. I don't really need anything else. I do need the y actually. Let me plug it in. So y is equal to negative 0.5 into 1 squared, which is just 1, plus 0.5 into 1 plus 3. So y is equal to negative 0.5 plus 0.5 plus 3, just 3. So I'm going to erase this because I don't need it. I'm going to write, instead of this, I'm just going to write, and ignore this, 1, 3. Okay, now, you might be asking, why am I needing this? Because I'm going to need it later. So, first of all, what do? You're going to find the equation of the tangent. Not the equation, just the derivative, the slope of the tangent. You're going to find the slope of the tangent, and then you're going to work with that. So, derive, 2 times negative 0.5 is negative 1. Negative 1x, so just negative x. Plus 0.5. So 0.5 minus x. Whatever. I'm pretty sure, right? Wait. Negative 0.5 times 2. Yeah, negative 1. I don't know why I'm doubting. Okay. So, that means that y prime is equal to y prime at x equals 1. This is going to equal to negative 1 plus 0.5. What is that equal to? That is equal to negative 0.5. Okay, so this is the slope of the tangent. Now, there's a rule in math you took in grade 7, grade 8, grade around that time. The slope of the tangent multiplied by the slope of the normal will give you -1. Okay, so essentially, what does that mean? The slope of the normal or the gradient of the normal, whatever. So this point here, remember the tangents are expressed in the form y equals mx plus b. Okay, m is the slope. So the slope of the normal is -1 over the slope of the tangent. In simpler words, okay, just to summarize it, just so you guys can get it really honed in, the slope of the normal is the negative reciprocal of the slope of the tangent. Just memorize it like that. Negative reciprocal. So -1 over the slope of the tangent. Done. Okay, so what are you going to do now? You have the slope of the tangent, which means that the slope of the normal is equal to -1 over -0.5. What would this give me? This will give me 2. Pretty sure, right? Wait, let me just check. -1 over -0.5. Yeah, it'll give me 2. That's not slope of my normal. Okay, so I don't need anything like this anymore. I'm gonna write it here. Okay, so I have, again, we're expressing it in the form of y equals mx plus b, right? I have m, so I have y equals to x plus b. Now what do? I have y, which is why I found y at the start. It's 3, right? And I have x, 1. So 3 is equal to 2x plus b. Or sorry, 2 times 1. Which is just 1, or 2, so I don't need it. Take 2 to the other side, b is equal to 1. Done. That's it. 2x plus 1. That's the end of this question. Okay, this is very, very easy. Let's rush through it. So y prime is equal to, take 3 down, 15x squared, minus 16x, plus 7. Remember, constant differentiates to 0. This is your answer. Okay, question 9. The point on the curve y equals x cubed minus 12x plus 5 at which the gradient is 12. Very, very similar to another question we just did. Y prime is equal to 3x squared minus 12. What do? You said y prime equal to -12. -12 is equal to 3x squared minus 12. Take 12 to the other side. You're going to get 0, right? Because this will be -12 plus 12, which is 0. So 3x squared is equal to 0, which means that x is equal to 0, right? So you have the x value. Now plug it into the original equation. So y is equal to 0 cubed minus 12 into 0 plus 5. This gives me 0. This gives me 0. So just leaves me with 5. And that's my answer. Question 10. Very, very similar. But it's much easier because you're not finding the equation of the normal. You're finding the equation of the tangent. So directly, okay, y prime is what? 2x minus 3. Okay, now plug in 3, so y prime at x equals 3 is 6 minus 3 is 3. So this is the slope of the tangent. Okay, so now I have it in the form of y equals to 3x plus b. Now, b I can find, I have x, I have y, so 0 is equal to 3 into 3 plus b. Remember, I'm plugging in x and y, so 0 is equal to, this is b, 9 plus b. So that means b is equal to -9, and that's my answer. Where am I? Oh, those are the Samsung notes. Okay, done. Now, the curve whose equation, consider the curve whose equation is y equals 4x cubed minus 5x plus 2. Okay, this is fine, not bad. The equation of the tangent, very, very easy. Let me just do it really, really quickly. So, how do you do this? You derive. Second. 12x minus 5. Okay, they want the equation of the tangent. So substitute x equals -1. -12 minus 5, right? Wait, no. Am I doing something wrong? One sec. So the derivative of this, what will it give me? So 4x cubed minus 5x plus 2 at x equals -1. That'll give you 7. How did I mess this up? Oh, this is 12x squared. That's why. 12 into -1 squared minus 5. What does this give me? This gives me 12 minus 5, which is 7. Okay, so the slope of the tangent is 7. Now, I'm not gonna need this now, because I just imagine I plugged it in here. It's in the answer. Now, what's y? I need y, right? So, 4 into negative 1 cubed minus 5 into negative 1 plus 2. What does this give me? 4 into negative 1 cubed minus 5 into minus 1 plus 2. 3. So the point is negative 1 comma 3. Okay, now plug it in. So 3 equals to 7 into negative 1 plus b. So that gives me 3 is equal to negative 7 plus b. Take 7 to the other, negative 7 to the other side. You'll get b is equal to 10. Done. Now, equation of the normal. Remember, the equation of the normal is the negative reciprocal of the tangent. So negative 1 over 7, which is the slope of the normal. Khalas, done. Now you're gonna plug in the form again. So you're gonna get negative 1 over 7x plus b. Okay, so what was the point? 3 is equal to negative 1 over 7 into negative 1 plus b. What does this give me on the calculator, because it's annoying to do by hand? So 3 is equal to negative 1 over 7 into negative 1 plus b. You'll get 20 over 5, right? No, what? You won't get 20 over 5. What? You get 20 over 7. You got 20 over 7. 20 over 7. Okay, so the equation is this, okay, which is fine. It's not bad. Here though, you can notice they expressed it differently. They didn't express it in the term y equals mx plus b. No, they expressed it in the term, in the form y ax plus by equals to c. Why? Because look, it's all fractions here, and no, it's not neat. So what they did is they took it to the other side. 1 over 7x plus y is equal to 20 over 7. Then just multiply it by 7 on both sides. Multiply by 7 on both sides. What will you get? You'll get x plus 7y is equal to 20. Which is their answer. 7y plus x is equal to 20. Same thing. Okay. Question 12. This one's a bit tricky. But if you, again, all of these questions, if you focus, you'll get them right. And they're very easy. But you just need to focus. So what do you do? Sorry, I think I cut. So, what you do here is essentially what you're gonna do is you're gonna separate this. So, what do you have? You have y equals radical 5x over the 6th root of x. What does this mean? You can separate this, right? You can take it as radical 5 times radical x over the 6th root of x. Now, you might be asking why I'm doing this, but it's actually gonna make sense in a bit. Now, remember, if you have radical, let's say it's the bth root of x power of a, this is equal to x power of a over b, right? So, what does this mean? This means you can express radical x as what? X power of 1 over 2, right? Because inside it's x power of 1, and outside, you know, when it's a square root, you have the 2, but you never really write it. So, you can rewrite this as radical 5 times x power of 1 over 2 over, here x is to the power of 1 and it's the 6th root, so x to the power of 1 over 6. Now why am I doing this? Because now, remember, if I divide exponents and they have the same base, I can just subtract them. So what is this equal to? This is equal to radical 5 times 1 over 2 minus 1 over 6, 1 over 3. And this is my answer. This is y. This is not y prime. Keep in mind, we're not done. Okay, now you can derive. This is the radical 5. We don't derive it. Why? It's called a multiplicative constant, and no, it's a constant that's multiplied by the thing we're gonna derive. Okay, so you don't derive those constants. If it's multiplied by x or whatever you're deriving, you don't derive them because here's why. Look, derive this. You're gonna get 1 over 3 times radical 5, because you remember you took the 1 over 3 down, into x power of 1 over 3 minus 1, negative 2 over 3. Okay, so what's this equal to? This is equal to radical 5 over 3. Remember, negative exponent means you take it down. So x power of 2 over 3 down in the denominator. Let me just fix this. So 2 over 3 radical 5. Okay, now this is very close to the answer, but all we have to do is change it back from exponent form into radical form. So how do you do this? Keep radical 5 the same, keep 3 the same. Remember, it's x to the power of a over b is the same thing as x power of a radical b, or you know, the bth radical. So it's 3 is our index. That's what we call an index outside. Okay, and inside it's going to be x squared, and this is your answer. Radical 5 over 3 into the cube root of x squared. Done. Question 13. Same concept. And it's actually, they should have started with this question because it's a much better introduction. So, y is equal to the fourth root of x. You can write this as x power of 1 over 4. Derive this. You're going to get y prime is equal to 1 over 4 x to the power of negative 3 over 4. Because 1 over 4 minus 1, negative 3 over 4. So that means just take it down. So it's going to be 1 over 4, the fourth root of x cubed. This is your final answer. Done. Why? Let's go slower. Let's go step by step. So you're going to get 1 over 4 into x to the power of 3 over 4 when you take it down, right? Remember the rule, this is the power inside, this is the index outside. So it simplifies to this. Done. But let's not overcomplicate it. So you can directly go into this. There's no need. Question 14. Okay. Again, similar application to this. So y is equal to x to the power of 10 over 10th root of x, so you can write it as x power of 1 over 10. What are you going to get? You're either going to do 10 minus 1 over 10. 99, no, x power of, what's this? 99 over 10. So, x to the power of 99 over 10. So, it's a big number, by the fraction. No, I don't know why they're doing it. Whatever. It's okay. You can derive this. So, y prime is 99x over 10. But the x is going to be subtracted from 1. So 99 over 10 minus 1. 89 over 10. So what does this mean? This means it's 99 10th root of x to the power of 89 over 10. But you can see here, and this is a very large answer, and x to the power of 89, even if it was 2 to the power of 89, is 6.19 times 10 to the power of 26. And taking the 10th root of that and multiplying blah blah blah, it's too long. So what you're gonna do, remember, what's x to the power of 89? I'm gonna keep the 10th root here. It's x to the power of 80 times x to the power of 9, right? So you can take the x to the power of 80 out. It'll be x to the power of 80 over 10, which is gonna simplify to x to the power of 8, right? Radical x to the power of 9, 10 here, which is the answer. So instead of this, I'm gonna rearrange it to 10th root, or sorry, x power of 8 times the 10th root of x to the power of 9. And this is your final answer. Done. Can this stop happening? Can I disable this? I don't like it. Never even used it. If y equals radical x to the power of, sorry, this is gonna equal to y is equal to x to the power of 5 over 2, right? Because remember, this is a 2 outside, but we don't write it. So derive, it's gonna be 5 over 2 x to the power of, what's 5 over 2 minus 1? 3 over 2. So you can rewrite this as 5 radical x cubed over 2, which is where they want us to stop. You can't simplify it. Remember, take it x cubed. This is the 2 here. It can be written as what? X squared times x. So you can take the x squared out. It'll be x power of 2 over 2, which is what? Just x. X radical x. So it'll be 5x radical x over 2. But here they didn't want you to do that. خلاص. Stop here. Done. Question 16. Very similar concept again. They just love testing this concept. I don't know why. So y is equal to radical 2 over radical 5x. Okay? Now, separate this down. So you're gonna get radical 2 over radical 5 into, straight away write it as x to the power of half. Okay? Why? Because you're gonna take it up. So you're gonna do radical 2 into x power of negative 1 over 2, because remember, we took it up, and it belonged down originally. So radical 5. So this is why. I don't need all of this anymore. Okay, now you can derive this. So you'll get negative 1 over 2 times radical 2. What's negative half minus 1? Negative 1.5, right? Negative 0.5 minus 1, negative 3 over 2, yeah. So x power of negative 3 over 2, which is negative 1.5, over radical 5. Now, you notice here you have a fraction, this denominator, you can instantly take it down, right? So what is it going to be? Negative, this negative 1, you're going to keep it if you want. You can remove it if you want. Radical 2 into x to the power of negative 3 over 2. Sorry, is there more space? I don't need to anymore. So, negative radical 2 into x power of negative 3 over 2. Okay, now remember, we took this down. So it's 2 radical 5. Okay, now, you take this back down, because you don't need it up there anymore. So negative radical 2 into, or sorry, just nothing, 2 radical 5 into, basically radical x cubed. Right, because x power of 3 over 2, and remember, it is, what it is just gonna be, taken down, right? So it's gonna be x power of 3 over 2, which is what, the second root or the square root, whatever you don't write it, x cubed. So, you can simplify this radical 5 radical x cubed, you can put them in the same radical. So negative radical 2 over 2 radical 5 x cubed, and this is your answer. Done. Question 17. Okay, this one, it's actually not that hard. And like, it looks hard and it looks annoying, but it's not that bad at all. Sorry, I have to go do something. Anyway, I decided I'd solve this in Samsung Notes because it needs space and it's actually a question that basically will not fit in that tiny space of the quiz that's given to me. So, they want us to find the abscissa of L. Now, let's read the question because what is abscissa L? What is L aslan? So, the figure below shows the sketch of a part of a curve with the equation 2y equals to negative 3x cubed minus 7x squared minus 4x, which means the x-axis at the origin O, point K at negative 1, 0, and the point L. Okay, so this is what L. L is essentially a root of the function. What does root mean? Root means it's when is y is equal to 0. So it's the value of x when y is equal to 0. Okay, so which basically the point where it meets at the x-axis. The moments of the curve at C at the points in K meet at the point M. Okay. First of all, let's find the equation of this function, right? Because they gave it to us in a weird way. They gave it to us as 2y equals to negative 3x cubed minus 7x squared plus minus 4x. But we can't work with this because there's a 2 here. So anything we do will be basically wrong. It will be doubled. So we're going to divide by 2. So negative 3x cubed minus 7x squared minus 4x all over 2. Now, I prefer to solve this, I prefer to leave this in decimal form. So, negative 3 over 2 is negative 1.5 x cubed. Negative 7 over 2, x squared. Minus 4 over 2 is just 2. Right? Remember, minus 4 over 2 is just minus 2. So, minus 2x. Okay. This is why. Why can't I... Oh, there we go. Okay. They want us to find the abscissa of L. Remember, L is a root of a function. It's this point here. This is L. Okay, this here is K, and this here is O. Okay, so to find the abscissa of L, you're just gonna plug in y is equal to 0. Because remember, it passes through the x-axis at this point, at L. So, negative 1.5 x squared minus 7 over 2 x, or sorry, this is x cubed. X squared minus 2x is equal to 0. Let me change this to decimal. What is this is 3.5. Okay, now you can do this on an equation solver. Or not equation solver, the mode 5.3. So you're gonna get negative 1.5 x cubed. Or actually, let's do it without the equation solver. Because some calculators can't do equation solver with cubic. So, take everything to the other side. You'll get 1.5 x cubed plus 3.5 x squared minus 2x is equal to 0. Okay, now x can be taken out as a common factor. So 1.5 x squared plus 3.5 x minus 2 is equal to 0. Okay, or wait, no, sorry. 1 second. No, I'm assuming this is correct. This is correct. Should be correct. So this means that x is equal to 0. Okay, that's our first point. But we already have this. This is point O. Now, x should equal... So you can do this on the equation solver because realistically no one's factoring this. Like, I think you're expected to do this on the mode 5.3. So 1.5, 3.5x minus 2. I did something wrong. Wait a second. Negative 1.5 x cubed. Yeah, okay. Sorry, my negative 7 over 2. Minus 3.5. Yeah, okay. That's 2x. Okay, give me a second. Okay, I realized what mistake I've made. Here, when I took everything to the other side, I forgot to change the sign of this one. I just did it now, so it's plus. Okay, do this into your equation solver. This equation, put plus 2 instead of minus 2. You'll get x is equal to negative 1. And x is equal to negative 4 over 3. Now, x equals to negative 1 is given to me as point k. This is point L. This is the abscissa, which is what I don't know. And this is what I need. So this is my answer. Negative 4 over 3, which is, as you can see, is what they want you to put. Now, the coordinates of M. Remember what they said. Okay. The normals to the curve at C, the normals to the curve C at the points O and K meet the point at M. So, here take this will be the tangent, so the normal will be something like this. Okay, and the normal of O, this will be the tangent, the normal will be something like this. Okay, so this here will be point M. Okay, now, how do you do this? As you can see graphically, what do you do? You find the normal of K, you find the normal at O, set them equal to each other, you'll get M. Very simple. So, coordinate of M. How do you do this? So, as we said, we're going to find the normal at K. Let's find the tangent at K. So, y is equal to minus 1.5 x cubed minus 3.5 x squared minus 2. Is this correct? Negative 1.5 x cubed minus 3.5 x squared minus 2. Okay, 2x. Now derive this. So y prime is equal to 3 times negative 1.5 negative 9 over 2, which is what? Negative 4.5 x squared minus 2 times 3.5 is 7. So negative 7x minus 2. Okay, now what is this? Is the normal at this is just this is the equation of the tangent, or the derivative, sorry. This is the derivative of y of the entire curve. This is the derivative of c. So dy by dx of curve c. Okay, so now what do you do with this information? Maybe it's just piss me off. First of all, find it at O. So at O, remember x is 0. So y prime is going to be minus 2. Right? Because this will give me 0, this will give me 0. So خلاص, I'm just left with minus 2. Now, what's the equation of the normal here? Remember, it's going to be negative 1 over negative 2x plus... we got the point O. Remember, O is 0, 0. So it doesn't matter. We won't have a B. So this is essentially my equation of that normal. So it's just going to be 0.5x. Okay, now at K, we're going to do the same thing. So y prime, add this one. This time it's at x equals negative 1. K is at x equals negative 1. So is equal to 9 over 2, or negative 9 over 2 x squared, so negative 1 squared, minus 7 into minus 1 minus 2. This gives me 0.5. This is the tangent. This is the slope of the tangent. So what are we going to do? The normal, the slope of the normal is negative 1 over 0.5, which is negative 2. So what's my equation? Y equals negative 2x plus b. Because since this we have a y now, which is what they gave us me the point 0. So 0 is equal to negative 2 into 1 minus 1 plus b. So I'll get 0 is equal to 2 plus b. B is equal to negative 2. That means my equation is y equals to x minus 2. This is the equation of the normal at k. So what do you do now? You set them equal to each other. 2x minus 2 equals to 0.5x. Take 0.5 to the other side, or whatever. Yeah. You'll get 2.5x is equal to minus 2. X is equal to negative 0.8. Okay, now this is x of m. However, they want the coordinates also, so they want y. Now, a common mistake I see people doing here is they substitute negative 0.8 into the function. No, because it doesn't belong to the function. You can see here, it doesn't belong to the curve. It belongs to the normal lines. So you're going to substitute x equals negative 0.8 to the... to any of the normal line equations. We're gonna use 0.5x because 0.5x is much simpler. So y is equal to 0.5 into negative 0.8. What's gonna give me negative 0.4? And this is my equation. So my coordinates is negative 0.8 comma negative 0.4. Done. Now the area of the triangle OKM. So OKM. Now, you can see here that this looks like a right triangle. You know why? Because it is. But obviously, we have to show it in the exam. And on the computer part, no one will care. They are. I'm telling you from now, they are. But how? This is my question. Well, a very basic definition of the tangent and the normal. Say your tangent was like this. Your normal will be like this. You notice they'll also form a right angle. Why? Tangents and normals, remember this. Tangent form right angles with normals, always. Now, how can we show this? Remember the definition, the slope of the tangent times the slope of the normal is equal to -1, right? So they're directly proportional or inversely proportional to each other. So mn is equal to -1 over mt, and mt is equal to -1 over mn, right? So essentially, this is how you show, just in a written part, show this if they ask it. I highly doubt that they'll ask this, but in a written part, state this and show it by stating this. Anyway, so since this is the right triangle, all we have to do is what? Find the distance from O to M and find the distance from K to M. Right? And then you can do half base times height. Now, what do? You use the distance formula. What is our distance formula? Remember, distance formula equals to radical x2 minus x1 squared plus y2 minus y1 squared. So we're gonna do this for both OM and KM. So let's do it for OM first. So remember, O is 0, 0. And this is negative 0.8, comma negative 0.4. So we're just gonna do this. So 0 minus 0.8 squared plus 0 minus 0.4 squared. Now, I took this as x2 comma y2 and this as x1 comma y1, which is why I did it like this. So you can take it the other way around. Obviously, it's fine. But no, this makes more logical sense since obviously, negative 0.8 is before 0. So negative 0.8 squared plus negative 0.4 squared. All under the radical, of course. You'll get, or sorry, this is plus. Doesn't really matter though. And a plus 0.8 squared plus 0.4 squared. Yeah, I'll get the same thing. So this is essentially 0.8 squared plus 0.4 squared, which gives you 2 radical 5 over 5 units. So what am I gonna write here? 2 radical 5 over 5. And then I'm gonna find, oh sorry, this is, so 2 radical 5 over 5 units. Okay, now to find OK. So, OK. O is what, or sorry, not OK. MK. This is what? Negative 0.8, comma, negative 0.4. This is what? Negative 1, comma 0. So, do it really quickly. Negative 1 minus 0.8 squared plus 0 minus 0.4 squared. So this equals 2, really just quickly. Minus 1 into just straight away, plus 0.8 all squared, plus 0.4 all squared, radical 5 over 5 units. So up here, alright, radical 5 over 5 units. Now, I use half times base times height, so the area is half times radical 5 over 5 times, what was the one before it? 2 radical 5 over 5 gives me, so half answer times 2 radical 5 over 5, 1 over 5, or what is this, 0.2 units squared. Now, I don't know if they used 1 over 5 or 0.2. They used 0.2. Done. خلاص, we're done with this question. Question 18. Can I move on? Thank you. Okay. This is very, very similar to the other question, the one with x plus delta x. It's extra practice, so I will do it. But I don't think it gets asked again, so we're good. Okay. P is 2 comma something. We'll find it right now. We can, since we have the function. Q is 2 plus h. What? And the variable point Q, the slope. So the slope is this. Okay. This is the slope of the line that's going to join them together. So 2 plus h, comma something. Now, we can find this really, really quickly. Yalla. So just plug in 2 into y. So 3 into 2 squared, which is 4, minus 2 into 2 plus 1. You'll get 2 comma 9. Now 2 plus h, so 3 into 2 plus h squared, minus 2 into 2 plus h plus 1. So you're gonna get here 3 into 4 plus 4h plus h squared, minus 4, minus 4, yeah, minus 2h plus 1. So you'll get here 12 plus 12h plus 3h squared, minus 4 minus 2h plus 1. This is very long. So 12 minus 4, 8. Plus 1, 9. So 9, okay, 12h minus 2h plus 10h plus 3h squared. This is my point. This is my y value for point Q. So 3h squared plus 10h plus 9. Why can't I write there? Okay, there we go. Now, what's the value of A? A is this. Oh, okay, so the slope of the secant AH plus 10. Okay, let's find the slope of the secant. So 3h squared, this is gonna be my x2 comma y2. This is x1 comma y1. So 3h squared plus 10h plus 9 minus 9 over 2 plus h minus 2. Can I stop opening Samsung Notes, please? Oh my god. Wait, I have to write it all again? What was it? 3h squared plus 10h plus 9 minus 9 over 2 plus h minus 2. Yeah, it's like this. So cancel 2 with 2, 9 with 9. So you're left with 3h squared plus 10h over h. Okay, factor h out. H into 3h plus 10 over h. H with h cancel out. This is an h. So you'll get 3h plus 10. Now, they told you the slope is AH plus 10. AH plus 10, 3h plus 10. So obviously A is 3, right? Because it's in the same form. Now, using part A, deduce the gradient of the curve at P. Okay, so we said that it is 3h plus 10. Okay, now, one second. Okay, so remember what we did last time? First of all, by the way, in a computer part, just don't don't use part A. This is annoying and no, it's not nice. If you want just derive وبعدين substitute, way easier. لأنه it's a computer part, literally no way for anyone to know. So what do? Again, remember what we did last time where we took the limit as h approaches 0, because this is the derivative. This is the basic principles of a derivative. It's called first principles. So this is what we're gonna do. Remember in the last time we took limit as delta x. Now we're taking it as h, but it's the same principle. So of 3h plus 10, what does this mean? It's gonna equal to 3 into 0 plus 10 gives me 10. This is my answer. Done. Again, computer part, no one will see. Just use the derivative function on your calculator if you have it. And if it's written, just show it. No, it's fine. خلاص. So what can you do? What's the derivative of 7x? Really quickly, this is just 7, because I don't need to explain it. Just 7. Okay. What's the gradient of the curve? So y prime is equal to 24x cubed minus 5. Substitute 2. So 24 into 8 minus 5, because x 2 cubed is 8. So 24 times 8 minus 5 is 187. That's your answer. Okay, I'm just going through these quickly. Okay, this comes. So I will do it. Consider the curve C whose equation is given by f of x equals to x squared minus 0.125x. If n is the line normal to C at 0, 0, and q5, s is a point on n, what must the value of s be? Now they gave you a hint. Find the equation to the normal at C and substitute 5 of x to find the y-coordinate of q, which is what you do. So let's follow this hint. Find the equation of the normal at C. So, no, you don't even need this hint. Say this wasn't given. Right? Say this wasn't given. They told you n is the line normal to C. Okay? And then they told you this point is on n. So what are you gonna do? You're gonna find this point, you're gonna find the y value of this point, and then just leave. That's your answer. So very easily. So derive this. So f prime of x, remember the notation of a derivative on when you're given f of x is f prime of x. Okay? So 4x minus 0.125. Okay? Okay, first of all, what do you do now? Oh, find substitute 0. So f prime of 0 is equal to 4 into 0 minus 0.125, which gives me just negative 0.125. So then you do the slope of the normal. This is the slope of the tangent, right? So slope of the normal is negative 1 over negative 0.125, which gives me negative 1 over negative 0.125, 8. So the slope is y equals 8x. Remember, since it's 0, 0, plus b will be 0, right? Because 0 is equal to 8 into 0 plus b, so b is 0, right? So whenever you see 0, 0, there is no b most of the time, but just triple check, double check, and it doesn't hurt. Okay, now this is the equation of the normal, right? Very easy. We found the equation of the normal. Now what do? They told you q has the coordinates 5, s. So you're gonna plug in 5, right? Because this is your x value. So y of the normal at x equals 5 is 8 times 5, which is equal to what? 40. That's your point. Done. Question 22. Seriously, this is 0. Don't let them trick you. Don't do 2 times 7 to the power of 1. It's not 14. No. Remember, the derivative is gonna be with respect to x. That's why they say dy by dx. Here, it's a constant. Because do 7 squared. 7 squared is what? 49. 49 what? 49x to the power of 0, right? Because remember, this is technically x to the power of 0, right? Take the 0 down. You're gonna get 0 times 49. So whenever you see a constant, remember the derivative of a constant is 0. Don't let them trick you with this. This is easy, but yallah, we can do it. Y equals to take this up straight away, x power of negative 3. So then derive, you'll get negative 3 x to the power of negative 4. So what is this? It's going to equal to y prime is equal to negative 3. Take the x power of negative 4 down, so it can be positive x power of 4. This is your answer. Okay, this was the end of the quiz. Good luck, guys. Have a great day.